Hello guys, today we're going to go over 1.2, which begins at page 89 of the PDF. Now there's a couple of things we have to know by the end of this section. Pretty much make and interpret dot plots, stem plots, histograms. We have to identify the shape and distribution of a graph. We have to describe the overall pattern, include shape, center, and variability of a distribution, and identify any major departures from the pattern, outliers, gaps, etc., etc. And then compare distributions of quantitative data using dot plots, stem plots, and histograms. Now, again, today we're going to go over about half of this material. We're going to leave the rest for another class. Now, to begin, we're going to start off with a dot plot. Now, honestly, I haven't seen this used a lot, but you just have to know what it is. A dot plot shows each data value as a dot above its location on the number line. So say, for example, I have 0, 1, 2, 3, 4, 5, 6. Has to be properly scaled, as all graphs. Let's say I have a couple of measurements, and the measurements are 0, 0, 1, 1, 1, 1, 2, 2, 5, 6. I have 2 zeros, so I put 2 dots on the 0, 4 ones, so I put 4 dots on the ones. And again, the dots have to be, they have to line up. I did this, I'm doing this as best as I can. I don't have graph paper. They do have to line up so you can easily see how many you have. And pretty much that's what a dot plot looks like. You have your axis on all your labels and your, let's see, you label the x-axis and you put the name of the quantitative variable on the x-axis and your scale on the y, and then you just put dots on top and you're pretty much done. Or actually, use the term scale incorrectly. The dots represent the actual measurements, so the scale would be on the x-axis. I mean, pretty straightforward. Describing the shape. Let's go over the pictures we can see on page 92. Now, let's say we have a distribution that looks like this. I'm just going to use like normal bell graphs. We kind of saw this in 10th grade already. When we have a distribution that looks like a bell, be it linear with histograms or with dots, doesn't really matter. If the information is spread in this way, it's pretty much symmetric, also known as normal bell curve distribution. When we have it lopsided to one side, it's either going to be positively or negatively skewed, also known as right or left skewed. Now, the way you have to remember this is the tail end points to where the skew is at. So this would be a negative skew or a left skew. This would be a positive skew or a right skew. The book shows you like a person skiing. Here you would ski to the left. Here you would ski to the right. That's a good way to know this, but I'd rather use tail like a mouse or a rat, because this is actually called the tail end. So the tail points to where the skew is. Left-handed or negative skew points to the left. Right-handed or positive skew points to the right. That's pretty much it for that. One thing to keep in mind, if we go over page 94, we have a distribution that looks like this. Again, I'm representing the dots with lines, but this can also happen with histograms and dot plots and a couple of other types of graphs. Now note that in this particular example, there are 2 peaks, and this can be considered clusters of data. So there are 2 peaks, there's clusters, there's a gap between these 2 peaks. And again, the peaks are like the modes, the values that repeat the most. If there's only 1 peak, it would be unimodal. If there are 2 peaks, bimodal. If there are more than 2 peaks, multimodal. We've kind of seen this already, but just a small refresher. Again, the peaks represent the most common value, modes. The next thing we have to do is go to page 95. It says how to describe the distribution of a quantitative variable. How to describe how the data is distributed on the graph. There's a couple of things we have to look. Shape, center, and variability. And also outliers, which are data measurements that kind of fall far away from other measurements. And there's actually a mathematical formula we use to actually determine which ones are outliers or which ones are just kind of a little bit far away from what's expected. We'll see that later. So for example, if you go to page, give me a second here. Let's look at some distributions. If you go to page, I do apologize. If you go to, I've said this a million times. If you go to page 98, we have an example of how housing varies in the United Kingdom and in South Africa. You can see that both have a single peak. They are somewhat clustered near these peaks. The only difference is that in South Africa, we have a couple of measurements on the right that seem to be outliers. There are no outliers in the United Kingdom. And as far as the shape, we can say that South Africa is somewhat skewed to the right. Well, not somewhat, it is skewed to the right. And the United Kingdom is somewhat skewed to the left because we kind of have like this measurement. It seems to be slightly skewed to the left. Only very slightly, maybe. If we see the graph on page 97 that has to do with highway fuel economy, miles per gallon, we see that there is a peak slightly under 22 miles per gallon. We have a cluster of data in the middle. There are some gaps with an outlier on the right-hand side and an outlier on the left-hand side. There are 2 gaps between these 2 values. There's a cluster of data in the middle, and there is a peak slightly under 22 miles per gallon. So pretty much that's how you describe the data you see in Dotplots. This also works for histograms, which we will see later. Now let's go over stemplots. Again, we see this in 7th grade, but we're gonna go over a slightly new concept. Now in stemplots, pretty much you can think of it like a stem and then the leaves on the right, a stem in the middle and the leaves on the right. Now pretty much the definition of the book states that a stemplot shows each data value separated into 2 parts. A stem, which consists of all but the final digits, and a leaf, the final digit. Stems are ordered from lowest to highest, arranged in the vertical column, and the leaves are arranged in increasing order out from the appropriate stems. So for example, let's say I have a value 66, 67, 69, 84, 101. Again, in my stem, I'm going to have all the values except the final value. I can't leave any gaps. So I have 60s, so I'm going to begin with a 6. I have no 70s. I have an 80. I have no 90s, and I have a 100. Now in the 60, I have 66, 67, 69. So 67, in order, 66, 67, 69. No commas separate these values. The 70, there is nothing, you leave it blank, because if you were to put a 0, that would mean you have 70. there is nothing there. 84, there's nothing on the 90, and 101. Pretty much that is a normal stem plot. Now, if you go down to section or actually page, if you go to page 103, you'll see that you have what's called a back-to-back stem plot, which has information both on the right-hand side and information on the left-hand side. The example we're seeing is a very good example that shows you the heart rate, or the pulse per minute, which is heart rate, resting on the left-hand side. Actually, let's go ahead and draw it. I have the resting side on the left-hand side. I have the stem in the middle, and I have the after exercise on the right-hand side. Now, in the stem, I have 6, 7, 8, 9, 10, 11, 12, 13, and 14, all the way down at the bottom. My erasers and my markers are just jumping off the board. They just don't want to be here at this time. Now, for the 60s, I have 8, 8, 8, and 9. Again, we always work away from the stem. So the smaller numbers are closer to the stem, regardless if I'm going left or right. Here I have 0, 1, 1, 4, 6, 6, 8, 2, 6, 8, 8, 0, 6, 4, and 0. And then on the after exercise, I have 80, 6, 7, 8, 8, 0, 2, 2, 4, 5, 8, 9, 9, 0, 4, 4, 8, 44, and 146 all the way at the bottom. Now, the interesting thing about these stem, back-to-back stem plots is that you can more or less visually compare the information of two events, one before, one after, for example. In this case, you can see that the average resting heart rate is below the average heart rate after doing exercise, because these values are bigger. One thing I didn't mention is repeat values. You just repeat the number. So if you have 292s, you put 0, 2, 2, etc., etc. You repeat values. And this is how a back-to-back stem plot works. It's somewhat useful, and it's easy to just see what the biggest number is, what the smallest number is. In order to find the median, you just count the amount of measurements, you find the one in the middle. So it's useful. I'd rather do a stem plot than a dot plot, that's for sure. But still, the best thing to do is probably, well, not the best, the ones I like the most, we use these a lot in medicine, histograms. Now, the definition of a histogram shows each interval of values as a bar. The heights of the bar show the frequencies or relative frequencies of the values in each interval. Now note, remember, we use bar graphs for categorical data, histograms for quantitative data. You can see examples of the same information displayed in dot plot form or histogram form in page 105. Again, pretty simple. If we were to describe the data we are seeing, again, it's a bimodal distribution. There's a peak at 2, there's a peak at more or less between 4 and 4.5. There's a peak between 1.5 and 2. There are two clusters near these modes. There's we wouldn't call it a gap because we do have measurements, but there's just a lull between those two clusters of information. Pretty much how to make a histogram. You can see the instructions on page 105. Choose equal width intervals that span the data. 5 intervals is a good minimum. Do not try to do a histogram with just 2 intervals. Use a couple. Try to do a couple. Pretty much you can just follow those directions. It's pretty straightforward. The x-axis gives you the intervals for the quantitative data. The y-axis gives you either the actual frequencies or the relative frequencies of the measurements. Pretty straightforward. Nothing new there. The descriptions work exactly the same for Dotplots and for histograms, so just make sure you know what you're doing. One thing to keep in mind, the Dotplots, when use a Dotplot and when use a histogram. There's a couple of instances in which Dotplots would be more useful than histograms. For example, if you're only working with whole numbers, for example, 6, 7, 8, 8, 8, 9, you could use a Dotplot or a histogram just as easily. I would rather do a histogram, but they are both equally useful. However, once you start segmenting the data, for example, if you have 6.1, 6.2, 6.3, 6.3, 7.1, and you have a lot of measurements, the Dotplot would not be as useful here because you would need a lot of more intervals. Here instead, you can do histograms. You have a 3 to 4 interval, a 4 to 5, a 5 to 6, a 6 to 7. Now, note that, for example, the 3 to 4 would be, values that are greater than 3 or less than 4. So just be careful with those values that are right on the edge. Or you can say that, this is 3 or greater, 4 or greater, 5 or greater, 6 or greater, etc., etc. So this bar would be all numbers from 3.4 to 3.999, 4 to 4.9, 5 to 5.9, and so on and so forth. So when you have a whole bunch of different decimals, instead of having to do a different interval or a different interval in a Dotplot to put just that one value, you can lump all those decimals into a single bar that will display all those values. So again, overall, in medicine, I don't see stemplots frequently. I've seen them very infrequently in certain studies. Never seen a Dotplot. I've seen a whole bunch of histograms and pie charts. Histograms and bar graphs probably going to be your bread and butter. So make sure you know how to do them and work on them properly. That's it for today. We'll continue with the rest of the section later on. Have a great day.